Hi, how's it going? Today we're going to look at sketching quadratics, okay? I was going to put sketching quadratic curves, but I started writing it and I couldn't fit it on, so sketching quadratics, okay? And with our curves, let's talk about the most basic one, shall we? The graph y equals x squared, okay? It's often called a U-shaped parabola. Let me just write that word on the board for you, okay? Parabola is a fantastic name, okay? It's a U-shaped parabola because it kind of looks like a letter U, okay? But parabola, okay, or parabolic are the words that we use to describe the curve, okay? Well, why does it look like this? Well, obviously when x is 0, y is 0 as well, okay? And when you square a value, you're never going to get a negative answer with real numbers, okay? So y is always going to be 0 or above 0. That's why the minimum point is there, okay? Just write it down for the moment. We often call that a minimum point. Okay, later on you might call it a stationary point, but for now I'll call it a minimum point. It's the lowest point of the curve. But then as x increases, okay, what happens to y? It also increases as well. Okay. Now I've written there as x becomes very large. Okay, it's a shorthand notation for saying as x becomes very large. It really means as x tends towards infinity. Okay, y also tends towards infinity. Okay, but it gets there at a much faster rate because you're squaring all the x values. Okay, if you didn't understand that, don't worry. Okay, just helping some of you out for what might be coming up in year 13 or even beyond. Okay. What I'm trying to explain is why the curve is actually increasing in its steepness as the x values increase, okay? So you just plot out a table of values. So you've got x values of 1, 2, 3, 4, 5, 6. The y values, of course, will be 1, 4, 9, 16, 25, 36. They're getting higher at a quicker rate, aren't they, okay? And that happens all the way up to infinity, okay? So as x tends towards infinity, y does the same, but at a faster rate. And that's why it's actually sloping upwards, and the gradient, we say, is increasing as it's doing so. Now the x values behave in exactly the same way, okay, because this is exactly the same as this, you see. I'll just put that in there as a generic negative term, okay. When you square any negative value, okay, it becomes positive. Remember, I'm talking about real numbers still, okay. And so the negative x values behave in exactly the same way. So it's symmetrical. That symmetrical property is really important, okay? The fact that you can draw a line of symmetry through its maximum or minimum point, this is a minimum point, is very, very important, okay? If it's a graph like this, y equals negative x squared with a negative in front of it, you just reflect the whole graph through the x-axis. So it becomes what sometimes is called an N-shaped parabola, but it's still a parabola nonetheless, and that will have a maximum point, okay? That's the very basic shape of a quadratic, okay? Let's just have a look at some variations on that, okay? Suppose you're asked to sketch any of these graphs. So I'm going to put just a couple. Y equals x squared plus 5, y equals x squared minus 2, okay? Those are very simple, okay? The plus 5 on the end there, or the subtract 2 on the end there, they just affect the y coordinates, because this is an equation to calculate the y coordinate given a particular x coordinate, okay? So if you add 5 to the y coordinates, you just shift the whole graph upwards. It's called a translation, okay? And so it looks something like this, you see? Where that's the minimum point there. Now on the coordinate 0, 5, I'm just going to leave that as a 5 there. And if you shift the whole graph downwards 2 units, it looks something like this. Just put it in there, start it there, and then, can you see what we're doing there? So you're just translating, shifting up and down the whole curve, okay? So these ones, they're very easy to do, okay? What about when you've got one of these, okay, where you've got it in brackets, okay? So x subtract 2 squared. What happens to the original shape of that, okay? Well, either you know it straight away, which is great, or just having a little time to think about it as I rub these ones off the board, okay? Well, the thing to do really is to consider where the minimum value is, okay? What's the minimum value, okay? The minimum value, okay, is still going to be when y is 0, okay? Because you're squaring these values inside the brackets, okay? So the smallest y coordinate you can have is 0, okay? What is the x value that will generate a y coordinate of 0, okay? That's the question you've got to ask. What is the x coordinate? And the x coordinate is 2. Because when x is 2 in the brackets, 2 subtract 2 is 0, and 0 squared is 0. You try any other number apart from 2, and then you won't get 0, of course, and you'll get to have to square that, and you get a larger value. Okay. So the minimum value is when x is 2. So what that means is, rather than have a minimum value at the origin, you just translate it, shift it 2 units across to the right like that. And that's why this is a horizontal translation towards the right. Okay, and I'm going to sketch the curve like this and like this. Now when you are sketching curves, it's often very good practice to find where the y and x intercepts are, or where it touches the y or x axis. With a parabola it will always cross the y-axis, okay, but the x-axis sometimes doesn't cross it, just touches it. More on that a little bit later, okay. It's easy to find because you just substitute x equals 0 this time, and you work out what y coordinate is. 0, subtract 2, negative 2, squared is 4, so the y-intercept there is 4, and that's it, okay. It's not a complete sketch, really, if you don't label where the x or y intercepts are, okay. So what about this one then? Y equals x, and we'll put plus 3 this time in the brackets. Okay. Well, same thing again. You're going to look to see where the minimum value of y is going to be. The minimum value is still going to be 0 because, you know, in mathematics this is how you've got to look at it. You've got to look at that as something squared where the smallest possible value is going to be 0. Okay. And so the minimum value is y equals 0. Try and find out what x must be to make that 0. Can you see in the brackets, to make that 0, x has got to be negative 3. So that means you've got the coordinate negative 3, 0 to draw, okay? So negative 3, 0, that's about there, okay? And then you just draw the parabola in, okay? Before I do that, I'm going to ask myself, does it actually cross underneath 4, through 4, or above 4? Okay, we'll just check that, okay? Easily done. Just substitute in x equals 0 for the y-intercept. 3 squared is 9, so it's going to intercept at 9, okay? So that means when I draw my parabola, it's going to go above 4, something like that, okay? And yeah, it's often useful to do a different set of axes for each sketch, otherwise it gets a bit messy, but this time I've just put them all three in the same axes so you can see the differences between them, okay? I'm just going to label that there as negative 3 as well, but it's complete, okay? So that's those ones, all right? Now, let me just, maybe just keep that on there for the moment. What happens then if you just put a number on the end, like say plus 5? Well, the whole graph just shifts upwards 5 units, okay? So what I'll do is, I'll take this graph there, that's the one I drew for x minus 2 squared, okay? I'll just shift that up 5 units, okay? And that is it, okay? And that is it. So, you can understand the importance of factorising and completing a square, because I answered many of these questions when you had a factorised expression or expression with brackets squared, didn't you? Okay, so let's give you an idea of why completing the square is quite important. Okay, now what if you've got an equation where you don't have any brackets in there at all? Okay, so what about y equals x squared plus x subtract 3? Okay, well, you try and see if you can factorise that. Okay. And if you can't factorise it, you do something else with it. Okay. You can quickly check to see if one of these will factorise or not by using discriminant. Okay, you remember you did discriminant before? Okay. In a nutshell, discriminant A, B, C stands for the A, the B, the C there. Okay. So you've got 1 squared, which is 1, subtract 4 times by 1 times by negative 3. Okay. And you get 1 plus 12, okay, which is 13. If that's not a square number, won't factorise. Okay. Won't factorise. So quickly you can just look at any quadratic and just check with the discriminant to see whether it will factorise or not. Okay. But what are you going to do then if it doesn't factorise? Okay. This is where you complete the square. This is where you complete the square. Okay. So a quick recap on that. Half of the coefficient of x. So that's half of 1, which is a half. So you get x squared plus 1x plus a quarter when you expand the brackets here. You don't want the quarter, so subtract it. And then you've got the subtract 3, okay? And then just rewrite it. That's y equals x plus 1/2 squared. And then just rewrite that as subtract 3 1/4. Yeah, I sometimes go for top heavy fractions, but in this case I'll just put subtract 3 1/4. Okay. Now, can you tell me how to sketch that graph? Think about it while I draw the axes. The question you ask yourself is, where is the minimum point going to be? Okay, what's the minimum value going to be? Okay, well, here the thing to do is look at the brackets. The minimum value of that is always going to be 0. So I'm just going to cover that up for the moment. Let's get rid of this. Okay, the minimum value of that is 0. So you can cover it up to simulate the fact that it's 0. What is the y coordinate? You're left with -3¼ So the minimum value is y equals -3¼ What is the x value that will make this minimum? Okay, so what's the x value that will make that 0? Because that's what we did. We looked at that being 0. What x coordinates do you have? It's got to be x is -1/2. That gives you the coordinates of the minimum point. Okay, so roughly -1/2 and -3¼ Let's just say down there, shall we? Okay, and that's the minimum point. Some of you might have done it by looking at the actual equation and said, yeah, in brackets that means shift it left ½ unit, outside the brackets that means shift it downwards 3¼ Great. Okay, once you are familiar enough to be able to do that, that is really good. Okay, that's a big time saver. Okay, you can just spot what the minimum value actually is. Okay, now I'm going to ask myself the question. Okay, where does it cross the y-axis? Does it cross it there? Does it cross it higher up? Let's just check. When x is equal to 0, let's just write this down actually. When x equals 0, y is going to be equal to 1/2 squared, which is 1/4. Subtract 3¼ and that's going to be -3, isn't it? Okay, so the y-intercept there will be -3. So I'm just going to put the parabola in like that. Okay, so there's the y-coordinate intercepts, just put it in there. Okay, of -3. Okay, I next should find where the x-intercepts are as well. Okay, how do you do that? Well, just as the y-intercept is when x equals 0, the x-intercept is when y is equal to 0. Okay, so you'll put this equals 0. Okay, so you'd have x plus 1/2 squared, subtract 3¼ equals 0, and you solve it. You work out what that is going to be. X plus 1/2 squared is equal to 3¼ Okay. I'm going to go for top heavy fractions this time, okay, if you don't mind. So it's going to be 13/4. Okay, and then when you square root both sides, you have x plus 1/2 is equal to positive or negative √13/2. I'm hoping you're happy with that. And then x is equal to -1/2 plus or minus √13/2, which I can write like this. Okay, those give my x-intercepts. Now, for the purposes of plotting a graph, sketching a graph, okay, it's a good idea to find out what they are as a decimal. Okay, so I'll just type that in. So -1 subtract √13 and then divide all that by 2. Okay, so that gives me value here. Just for your purpose, I'm going to write -2.30 to 2 decimal places. Okay, and that coordinate there, I'm just going to rework that. So -1 plus √13, okay, divided by 2, and that gives me 1.30. It's 2 decimal places. Okay. And if you want to, you can label the coordinates and the minimum point as well, which is -1/2, -3¼ Alternatively, what I often do, okay, is I actually write down the exact value. So there I'd write -1 plus √13/2. There I'd write -1 subtract √13/2. Now this example, okay, is about as difficult as most questions get in terms of graph sketching, okay, because it's an equation that doesn't factorise, so immediately makes it a little bit harder, okay, so you have to use the complete and the square, but as long as you follow the steps I mentioned in terms of looking to see what is happening here with the minimum point, or looking to see what's happening with the translations, then that's pretty much how to sketch your curve. Okay, I'm hoping you're happy with that. Let's do another one. Okay, let's do another one. And just in case you found that a little bit hard, I'll do an easy one next, just to raise your confidence a little bit perhaps. Okay, so let's do y is equal to, y is equal to x squared, let's do plus 5x plus 6, okay. That's an easy one because I've given you one I can factorise. Sorry, I was thinking ahead, wasn't I? I put a bracket, originally I wrote it down, that's because I was thinking ahead as to how you'd factorise it, okay. Hopefully you're good with the factorising now. Okay, so x plus 2, x plus 3. That is really nice and simple, okay. Why is it nice and simple? Well, it's because you can do this one just by considering where the graph crosses the x-axis, okay. So in solving the equation, x plus 2, x plus 3 equals 0, each of these brackets tells you where it crosses the x-axis. So -2, -3, okay? So I'm going to put them in here and there. Okay, it's a sketch, so I can space it out a little bit, okay? And because they go through there and there, okay, I can then just draw my U-shaped parabola in, okay? So I can do it like this. There we go. Right. Note that that is an incomplete sketch, okay? I did mention earlier that all parabolas will cross the y-axis at some point because it goes on forever, you see. Okay, that's slightly better, okay? You should label each x-intercept, -3, -2, and find the y-intercept as well, which is easy. Put x equals 0 into the top part or the factorised part, you're going to get 6 either way, aren't you? Okay. That's why that's an easy one, okay? But how would you find where the minimum point is in this case? Okay. Well, completing a square in the previous example helps us with that. So what you're going to do, you're going to go back and complete the square on this, just so you can actually find the minimum value, okay? You don't have to, okay? Remember the property I told you about earlier, where each parabola is symmetrical, with the line of symmetry through its minimum point, okay? Well, because it's symmetrical, what it means is the minimum value is going to be exactly halfway between x is -3 and -2, okay? And of course it's -2.5, isn't it? Okay, so -2.5, right, this time around it's a top-heavy fraction, -5/2, okay? So that's the x-coordinate. Now you need to find the y-coordinate. Find the y-coordinate by substituting it into there, okay? So if you substitute it into, I'm going to put it into the factorised one, okay? So -2.5, so you might find an easy thing like that, plus 2 is -0.5, so it's -1/2, okay? And then -2.5 plus 3, that's going to be +1/2, okay? So -1/2 times +1/2, that's -1/4, okay? So that's, you can check at the calculator if you wish. Okay? So that's the coordinates of the minimum point there, okay? I'm hoping you found that fairly straightforward. Let's do another one. Okay, let's do another one. By the way, I'm trying to restrict most of these to the U-shaped parabolas. Okay, just because it's easier. I mean, it's easier to get to grip with in terms of sketching the quadratics. Okay, so y equals x squared plus 10x plus 25. That one factorises again, but this time it factorises x plus 5 squared, okay? Now you've done the bit in the quadratics chapter that talks about repeated roots, okay? So this would be a repeated root of x is -5, but what does that look like in terms of a graph? It means there's only one value on the x-axis that you can plot that you know the curve is going to have an interaction with, okay? I call it an interaction because I didn't want to say intercept. Okay, an intercept is a different thing, okay? An intercept means it goes all the way through the axis like that. It literally crosses it, intersects it, okay? But this doesn't actually happen, okay? It can't happen because it can't go through there, can it? Because all parabolas will have a minimum point if it's a U-shaped parabola, okay? It has to come back at some point and have to go through the x-axis again somewhere. Or if it goes through this way, have to come up again somewhere, okay? But there's no other place where it crosses the x-axis. If it did, then there'd be another bracket in there with a different expression inside, okay? So for that reason, we know it only just touches the x-axis, we say, okay? It just touches the x-axis. Okay, so I'm going to put the -5 in there again. Because it touches the x-axis, okay, the minimum point is precisely on when x equals -5, okay? And then you just extend the graph so that it crosses the y-axis as well. Put in x equals 0 into there or there, you get 25. Okay, that's done. Possibly even easier than the previous one I just did, simply because there's only one x-intercept. Okay, I think they're just as easy. Okay, okay, that good. Right, let's do another one. Okay, so we'll go back to one that doesn't factorise again, shall we? So x squared plus 2x plus so I was just hesitating, I couldn't really decide. I'd go with plus 3. There's no point in making it really hard, just think about which number to put in there. Okay. So I told you it won't factorise. Again, you can check that. Let's just use the b squared minus 4ac, shall we? Okay, so b squared is going to be 4, and then subtract 4 times 1 times 3, and that's 4 subtract 12. Oh, look at that. Negative 8. Negative 8, okay? Not only is that not a square number, so it doesn't factorise, it's a negative value. Can you remember what the discriminant tells us when it's a negative value? It means there's no real roots. Complex roots, yes, but no real roots, okay? Which means it doesn't cross or touch the x-axis at all, okay? There's no solution. So that would be an interesting one for us to consider, okay? But it does have a minimum value. I'm going to use completing the square to try and find that, okay? So again, a reminder, we're going to halve that value there to get x plus 1. That gives us x squared plus 2x plus 1. Subtract the 1 and then plus the 3. Okay, that's complete the square bit. But of course, subtract 1 plus 3 is the same as just plus 2, isn't it? So I can rewrite it like that. Okay. So let's just draw the axes. There we go. Okay. Incidentally, try and always label these with arrows and x and y. Just pleases me if you do so more than anything. Okay. No, you don't get in A level. You don't get marked down if you don't put the arrows and the x and the y. But it's just, like I say, pleases me and most maths teachers. Most math teachers like it when you label stuff. Okay. Because we like order, you see. We like to have a sense of order with things. Okay, and it looks like a nice ordered diagram when it's got the x's labelled. All right. So where's the minimum value of y going to be? Okay. So minimum value is going to be y is equal to, what do you think? Well, again, we look to the brackets. Something's squared, lowest possible value is 0. So I'm just going to cover up that for the time being. Okay. You could do that in your notes when you're going through these. If you want, just use your fingers to. That's what I do sometimes. Okay, just to cover up when you got something is 0. Okay, saves you having to write it out again basically, rather than write y equals 0 plus 2. So you got y equals 2 is what's left over. Okay, and what is the x coordinate that will make that happen? From the bracket, if x is negative 1, you get 0 in the bracket, don't you? So when x is negative 1, and that gives you the coordinates of the minimum point, okay? So negative 1, 2. So negative 1, 2, it's about there. Now, because that's the minimum point, okay, can you see that it's not crossing the x-axis or touching the x-axis, is it? Okay, because it's already started above the x-axis. Okay, so that helps us to make sense of the discriminant there being negative, the fact that there's no real solutions to that. Okay, so on this, there's only a couple of things we can do really. That's to label. Let's do it on this one, where the minimum point actually is, there, negative 1, 2, and let's find where the y-intercept is as well. So that's just going to be 3, okay, and that is it, okay, that's it. Okay. Should we just do one more, okay, maybe just one more, because I've not done any of the type examples that I'm about to show you, okay. Like I said, I've stuck to mainly U-shaped parabolas, okay, but let's just do one that's obviously not a U-shaped parabola, okay. Y is equal to 10 subtract, what should we have? X minus 2 squared. Okay. Can you see why it's not going to be a U-shaped parabola first of all? Okay. Right, you don't have to do this. In fact, it's preferably you don't do this. But let's just expand the brackets and see what you get. So you get 10 subtract. So x minus 2 squared is x squared subtract 4x plus 4. Notice I put the brackets there because look, I've just expanded that and put it there, but you're subtracting this. So common error occurs in these sorts of questions where you don't consider the negative there. So then you've got 10 subtract 4, which is 6, and then you can have plus 4x, and then subtract x squared. Now why have I written it out like that? Because traditionally in mathematics, when the x squared term is negative, we tend to write it out like this, okay? It's just one of those things. We tend to write it out in ascending powers. Okay, we talk about ascending powers, increasing values of x, x to the 0, x to the power 1, x squared, or descending powers, x squared, x to the power 1, x to the power 0, which is just the constant. Okay, you'll see more of that in the binomial expansion. Okay, anyway, can you see the important thing there is the x squared term is negative. Okay, so that means it's going to be an n-shaped parabola. Okay. By the way, in class, I never use this technique that I'm about to mention to you, okay, but something I'm going to mention just for this video, okay. A negative, it's sad because it's negative, and a sad face looks like that, doesn't it? Whereas a positive x squared graph, a positive, all happy, smiling now, okay? And smiling, happy means it's a U-shaped parabola. If you want, okay, I just thought I'd mention that. Okay. I just don't do that in class because I might just get laughed at the silliness of doing that. Okay. Anyway, so what I'm going to do is I'm just going to rewrite this here to give myself a bit of space, okay? Because I might refer to it, I don't know, after I've drawn the curve. Because I've done the working, I don't want to have to do it again, okay, later. So we're going to have a go at sketching this. So let's just get the axes. Now bear in mind it's a N-shaped parabola this time. Okay, that means it's going to have a maximum point somewhere. It's going to be a bit at the top that's the highest bit. Okay, so this time I'm going to write down a maximum value. Okay, a maximum value of what y could be. Okay, and we're going to do exactly the same thing as for finding a minimum value. Okay, that is look to the squared bracket. Okay, now the minimum that can be is 0, isn't it? Okay, so if I just cross that out for the moment, just standing by here, okay, I'm going to get 10 subtract 0. That's the highest possible value you can have. Why is that the highest possible value you can have? Because if that was not 0, if that's a different number, then you square it, you always get a positive value, okay? Because if you square a positive number, you end up with a larger positive number, or at least a positive number. Say, if you square half, it's not exactly larger as it's smaller, but you know what I mean. The main point is when you square a positive value, you still get a positive value. You'd be subtracting that, and 10 subtract a positive number is going to be lower than 10 subtract a number. What I'm saying is you want to subtract the smallest possible number to end up with the largest possible y value. So if you subtract 0, you get y is equal to 10. And that's why the maximum value is when y is equal to 10. I'll come back to this side. Much more comfortable over this side. Possibly because I'm right-handed. No, I'm not sure. And then when is that going to happen? That's going to happen when x is equal to what? What makes the bracket 0? It's x is 2. Okay, when x is equal to 2. And then you've got the coordinates of the maximum point there. So 2, 10, so let's just say there, okay? That's going to be a maximum point, okay? What's the y-intercept going to be? Well, maybe if I use that equation there, when x is 0, y equals 6. But if you didn't have that written out from this, of course, when x is 0, negative 2 squared is 4, and 10 subtract 4 is 6. So again, it's going to be 6. So you've got a y-intercept there, and I'm just going to keep the curve going downwards like that. Okay, so what did I say that was? 6. I said the coordinates of that point there was 2, 10. Okay, and then we should really work out what the x-intercepts are as well. Okay, we should really do that. Okay, so in finding that, we should solve when this is equal to 0. Okay, so you've got 10. Okay, do you mind if I just... No, sorry, I forgot what I was about to say. I'll just write the whole thing out. I was going to take a shortcut, but no. That's not what these videos are about, is it? Not take shortcuts, just do the whole thing. So that is equal to 0. Okay? So that means that your x minus 2 squared is equal to 10. If I just put the 10 to the other side, okay, and just swap them around, okay. And then x minus 2 is equal to positive or negative square root of 10. And then x is equal to 2 plus minus square root of 10. Okay, I think you can see that that coordinate there is going to be the 2 plus root 10, and that coordinate there is going to be the 2 subtract root 10. You can see because that's the larger value, the 2 plus, that's the smaller value, the 2 subtract, isn't it? But if you want, you can work out there as a decimal, so that's going to be 3 point something. I'm going to say 3.1. Okay, so 2 plus 3.1, about 5.1. 2 subtract 3.1, okay, obviously negative, so that fits with it being in there. Okay. Right, that's it. That's quadratic graphs in a nutshell. Okay. Hope you got something out of that. Okay. Hope you enjoyed that. Hope it was useful to you. Okay. And look out for future videos where I'll be looking at cubic graphs. Okay. Bye bye.